All right, thank you so much for joining us today. So we've learned a lot. Unit vector, position vectors. We talked about scalar product or dot product, and we looked at two-dimension, three-dimension, and we looked at coplanar vectors, right? And then doing dot product, we saw that we were looking at angle between two vectors. But in this video, we are going to look at angles between two planes, right? So here we are looking at plane, not vectors, right? So let's start. So let's assume that we have a plane, right? We have a plane. So let's start with, let's assume that we have a plus by plus c z plus d to be equal to 0 to be a plane, right? So let's define another one, plus b1 y plus c1 z plus d1 is also equal to 0. So let's assume that we have these two planes here, right? So we have this and this. So these are two equations of the planes, right? So anytime we have planes, then what we need to do is we need to find their normals, right? The normal vectors, right? So whenever you have a plane and you want to convert it to a vector, we call it normal vector, right? So what we are going to do is we are going to convert these two planes, let me say equation 1 and equation 2, into normal vectors. So they are normal vectors. So the normal vectors is given by So from A, let's assume that that one is n. So we are going to have, remember when you're talking about vectors and we are having x, y, z, then it means that we need to have it in direction. So when I find the normal vector for the equation 1, I'm going to have ai plus bj plus ck. The d will go to 0 because we don't have any direction attached to that. Then my n1 will be equal to a1i plus b1j plus c1k. So this is how it is. So anytime um, a plane is given to you, then for you to do anything or for you to find the angle between them, the first thing that you need to do is you need to find the normal vector before you can think about finding the angle between that, right? So now we know that we know how to find angle between vectors. So here we are trying to talk about angle between two planes, but for us to talk about the plane, we need to convert it to what? Vectors before we can do that. So here we know that the angle between n1, the angle between n and n1, which are the normal vectors, is given by, which we know it already, is given by a dot a1, which is equal to the magnitude of n1 cos of theta. So remember when we started dot product, we did something like this, which we were talking about a1, a2, a1, a2 cos theta. So it's the same thing. The only thing here is now we are talking about the normal vectors, and we need to replace the a1 and a2 by the normal vectors that we've learned here. So it's the same process that we are going to go through. Now here, remember, here theta is the angle. Theta is the angle between the plane, not the vectors. Yes. So that's what you need to know here. So here, when I make theta the subject, you know that definitely I'm going to have theta to be equal to cos inverse of n1 or n dot n1 divided by magnitude of n, magnitude of n1. So this is what I'm going to get for finding my vector. Yes. So yeah, this is what you just need to do. So let's take one example and then let's see what we can do. So find the angle between the plane, then we have this and that. So these are the equations of the plane, right? These are the equations of the plane. So now we have x minus z, which is equal to 0, and we have y minus z, which is also equal to 0. So now what can we do here? Now we need to convert this to normal vectors. So let's assume that the first one is n. So I'm dealing with this one. This is x and z. So I'm going to have I minus k, right? As we did from here. So we pick the coefficient of a, then we multiply by I, coefficient of b, we multiply by j, coefficient of c, we multiply by, coefficient of z, multiply by k, right? So the coefficient of x is 1, 1 times I is this, coefficient of z is minus 1, and then we multiply by that. And our n1 will be equal to coefficient of y is 1 times j minus k. So this is what you are going to get. So these are the normal vectors, right? So we need to go through the same process to find our theta. So we know that theta is equal to cos inverse of n dot n1 divided by n dot n1 with magnitude. So the same thing. So we just need to know n dot n1. What are we going to get? I minus k, then j minus k. So remember, we need to dot direction by direction. So I times, we don't have I here, so the I here is 0. So it's going to be I times 0, and it's going to give us 0, right? And then we don't have j here, so let me even rewrite this one. So this one, because we have ij, this one can be written as I plus 0j minus k dot 0I plus j minus k. So I times I, this is going to be 0. 0 here times this one is also going to give us plus 0. And this times this is going to give us plus 1. And we are going to have this to be 1. So when I dot them, that's what I'm going to get. Let's look for magnitude of n. So this is going to be 1 squared plus 0 squared plus minus 1 squared, right? So that's what I'm going to get, because I don't have j is 0. So I have it this form, and this will be 1 plus 1, and this is going to give me root 2. What is n1 magnitude? That one we don't have I, so I'm going to have 0 squared plus 1 squared plus minus 1 squared, and I'm going to have 1 plus 1, which is equal to root of 2. Now what can I do? I need magnitude of this times magnitude of that. So root 2 times root 2, and this is going to give us 2. So now, since everything is set, this implies that theta is equal to cos inverse of n dot 1, n dot n1 is 1, and then when you multiply that one, we had 2. So all we need to do is, on the calculator, let's check cos inverse of half, and we are going to have 60. So it's the same thing that we did under dot product or scalar product, but the only thing here is we need to make sure that here we convert the plane to their normal vectors before we can go through the whole process. Right, right, right. So what I can do is I give you this one to also try, right? So I want you to find the angle between the two planes, this and that, right? So that's what we are going to do. So define your normal vectors for the first equation and then the second equation. When you are done, drop your final result in the comment section. Good. Let's look at the last one here. Now we can also talk about angle between a line and a plane. And this is so interesting. The idea is that, you see, the way we've done something here, you see, there is a possibility that you can have two planes and one line, right? So you need to make sure that you convert them before you can use the idea. Now, whenever we are dealing with angle between a line and a plane, then we need to look at the idea that the angle will be like, we are going to have two solutions, right? So we are going to have so what we can note here is we are going to have something like when theta is greater than 90 and when theta is less than 90, what do we do, right? So when it is less than 90, when it is greater than 90, then our theta 1 should be equal to theta minus 90, right? Because it is greater than 90. And then when it is less than 90, then theta 2 will be equal to 90 minus theta. So we are going to go through the same process that we are doing here, the same um, using the same dot product formula that we learned, and we are going to go through the same process. But these are the basic information that we need to also learn from here, subtracting the answers that we are getting from 90 or 90 from the final results that we are going to get, right? And I'm going to show you some examples, like real examples that we can go through that. So if A and B are points in the space given by this and that, find the angle between the line AB and the plane. So you see what now it is happening here. Now we want to find the angle between line AB and the plane. So it's the same process, but what we just need to do is now we need to have two vectors, right? We just need to have two vectors. So we need to have this vector here and this. So the only thing that we need to do here is now we need to find for the normal vector, right? So we are saying that I'll first let n to be equal to the normal vector of the plane. So it means that my n will be equal to, from here, what will be my n? It will be I minus 4j minus 3k. So I'm just replacing the x and y by their direction. So x is I, y is j, and then z is k. So I'm having my normal vector here. So for me to go through the dot product to find the angle between the line and this, I need to have AB. So let's find AB. Now vector AB is equal to B minus A, where B is the position vector of big A and small a is the position vector of this. So what is B? B is the position vector of that. So what? Okay, even given already. So that one is already given. So now what we just need to do is let's just plug them in. So I have I plus j plus k minus 3I minus j plus 2k. So let's try and simplify that. So same direction, I to I. So I'm going to have minus 2. I'm going to have I minus 3I plus j plus k minus 2k. So this minus that plus j minus minus will be positive, and then k minus 2k. So this is going to give us minus 2I plus 2j minus k. So now I have this and I have that. So now what I'm going to do is I want to find the angle between n and the vector. So we know that this is supposed to be equal to AB, which is equal to the magnitude of AB dot n dot cos of theta. So it's the same thing, but it's just this which keep changing, right? So that's all. So what will be theta? The same idea. Theta will be cos inverse of A dot n divided by the magnitude of this and then magnitude of that. So all we need to do is dot them, find the magnitude, and then just put it on the calculator, then you are done. So it's very simple. So let's vector AB dot n. This is going to be minus 2i plus 2j minus k. Then n is I minus 4j minus 3k. So let's do that. This time this is going to give us minus 2. This time this is going to give us minus 8. And then this time this is going to give us, don't forget this is 3. This is going to give us plus 3. So this should give us minus 7. Let's find the magnitude of AB. So minus 2 squared plus 2 squared plus minus 1 squared. So this is A. We are finding the magnitude. So minus 2 squared minus 1 squared. So this is going to give us 4 plus 1. And this is root of 9. And this should give us 3. Let's find the magnitude of n. What is n? 1 squared minus 4 squared, 9 squared. So we are going to have 1 squared minus 4 squared plus minus 3 squared. So we should have root of 1 plus 16 plus 9, and this one should be root of 26. So let's multiply, since we have this times this, let's multiply this and that. And what are we going to get? AB dot magnitude of this is going to give us 3 root of 26. So it means that theta is going to be cos inverse of, what did we get for the dot? We had negative 7. So negative 7 divided by 3 root of 26, because this is here. Then just do that on calculator and we are going to have something like 117.2 degrees. Right. So this is what we are going to get from finding this. Now we can see that we are having this one to be 117.2. So what we are going to do is we want to find the angle between these two lines, right? So what we are going to do is, remember, we need to have two solutions. So this is, let me make this one theta, and let me make this one theta star. Now theta star is going to be 360 minus theta, which is 117.2, and this one should be 242.8 degrees. These are not the angles. The original angles, remember, we need to check if it is greater than 90, as I said here. If it's greater than 90, then the original angles, which is theta 1 and 2, this is what we are going to do. So now let's compare them. So what will be theta 1? So this will be the final solution here. Theta 1, this is greater than 90, so we are going to have 117.2 minus 90, and we are going to have 27.2 degrees. Then what will be theta 2? Theta 2 too, we can see that this is also greater than 90, so we are going to have 242.8 minus 90, and this one should be equal to 152.8. So this is what you are going to get for the angles between the planes. Wow. Wow. I hope you enjoyed it. And I have one question for you to try. But this question, basically, I need to come in, right? Because you see that we want to find the angle between the lines, this, and then the plane. But you can see that this line here is in the plane form, right? So first we need to find the normal vector for this. So let me just give you the hint. So let me assume that R1 is equal to I plus 3j minus k, and r2 will be equal to 2I minus j minus k. And when you finish, you need to find r1, r2. So this one is going to be r2 minus r1. So you want to find this vector so that this one will be together. So this is going to give us 2I minus j minus k minus 2j minus k. So simplify this and you are going to have I minus 4j, and then it will be 0. So the k aspect will be 0. Then when you finish, you find your normal vector, which is being 2I minus j plus 3k. Then you use this and this to do what I've done here. Yeah. So go through the same process and then put your final result in the comment section. So I think, yeah, that's all I have for you in this video. So we talked about angle between a line and a plane, and then we talked about angle between two planes. I hope you enjoy it, and see you in the next video where we are going to talk about cross or vector product.